they're adiabatic. So doing this NR, TC, and so on, you will end up with this. TC V1 to the gamma minus 1 equals to TH V4 to the gamma minus 1. Now you can divide the two equations by each other and see what you get. So let's divide it. Let's divide this equation by this. So if you do this over this, you will get TC over TC is 1. And then V1 to the gamma minus 1 divided by V2 to the gamma minus 1, so you get this. So if you divide these, you will get V1 to the gamma minus 1 over V2 to the gamma minus 1 is equal to V4 to the gamma minus 1 over V3 to the gamma minus 1. And you can combine these under the same power. So V1 over V2 to the gamma minus 1 is equal to V4 over V3 to the gamma minus 1. If you raise two things to the same power and they're equal, it means those two things are equal. Right? Both sides have the same power. So that means V1 over V2 is the same as V4 over V3. Right? So this implies that V1 over V2 is equal to V4 over V3. So V1 over V2, V4 over V3, natural log of the same thing. So this cancels, and we end up with the efficiency is 1 minus TC over T hat. So what is this efficiency? Is it the max or no? Yeah. So this Carnot engine will have the maximum efficiency, and yeah, you can beat it. Yeah.
Can you pull the board back down?
Yes. I thought in the back maybe you can see the lower area. Yeah, I think we're enough of time. That's it for thermodynamics. Well, for this semester, mechanical engineers, you will have more in your upper level courses.